now we are going to study about how resistivity changes with temperature, right? So first of all, we are going to talk about metals. First of all, we are going to talk about metals. Okay. Now, let's just have a look at the formula again. Rho is equal to Fe upon Ne squared tau. Okay, that's what we do. Now, what would happen as temperature would increase? Exam mark है ना लगता है व्यवस्थित लगता है. As temperature would increase, mass of electron change था, okay? Charge of electron. So you don't have to worry about this. Just worry about N and tau. First of all, let's go to tau. It's easier to understand. Is that in metal, the ions are there, and if temperature will increase, random motion of ions will also increase. Now think of a very simple case that in one possibility, when something wants to move, let's say I want to move, and everyone is sitting still, then the chances of collision are very less. Correct or not? Compare that to another situation where someone has to move, but other people are randomly moving here and there, or they are just going left, right like that. So chances of collision are more. Yes or no? Clear or not clear? Chances of collision are more if everything is moving. But if only one is moving and others are relatively not moving, then chances of collision become less. So as temperature would increase, do you realize that the random motion tendencies will increase? Yes or no? That's simple as that. Kinetic theory of gases में आता है. If temperature will increase, the random motion will increase. So when random motion of ions will increase, obviously number of collisions will also increase, and that would mean collisions will occur more frequently and relaxation time will decrease. Is that clear? And relaxation time will decrease. Understood? Clear or not clear? Okay? Fine? Everyone gets this? Now, if relaxation time will decrease, that will contribute to increase in resistivity. देखा है? If relaxation time will decrease, it will contribute to increase in resistivity. Understood? But what about N? What is N, by the way? Number density of electrons. So number density of free electrons actually means that how many free electrons are there per unit volume. Now as temperature will rise, more and more atoms will get energy, and you know when metal atoms get energy, they can throw their electron out, they can lose their electron. Yes or no? By gaining energy, they lose their electron. Correct or not? Yes. Fine. But what happens is that metals are those kind of materials where even at a very low temperature, most of the electrons in the valence shell have become free. I repeat what I have said. Metals, even at low temperature, have most of the valence electrons free. समझाऊँ? You know समझाऊँ? तो તમે temperature increase करशो तो जे already free છે, એ free થાય, तो જે છે એ તો એમ જ રહેશે ને? Correct or not? Is that okay or not okay? It's like, think about it. If you all, for example, need 16 marks to pass out of 50, and most of you have already passed, then if I give 5 grace marks to everyone, तो कितना पास थे एमा શું ફરક પડે? There will be a difference, of course. The number of students passing will definitely increase, but it will not increase that much. Already suppose out of 40, let's say 35 have passed, તો પછી ગ્રેસિંગ આપે તો બહુ બધા પાસ થઈ જાય, બીજા બધા 60 નવા આવી જાય પાસ થયેલા, ક્યાંથી આવે? You understand? So what I am saying is electrons of metals, especially the valence electrons, at ordinary temperatures, at room temperatures or even less than that, they are already free. Why? Because from the temperature, whenever something has temperature, collisions are going on, vibrate. So because of that, atoms will get some energy and they will lose their electron. Okay, the mostly બધાનો electron જતા જ રહ્યા. તો હવે already બધા free જેવા જ થઈ ગયા. તો એમાં તમે વધારે energy આપો, that is you increase temperature, you give more and more energy. Yes or no? એ તો સમજ પડે જ ને. Giving energy means you are increasing temperature. Clear or not clear? So if you give more energy, that is you increase temperature, will more electrons become free? Yes, but very little. એના જેવું છે એક્ઝેક્ટલી ઓલું પાસિંગ છે. ઓલરેડી 35 have passed. વધારે માર્ક્સ આપું તો બીજા 50 પાસ થઈ જશે. છે જ નહીં ને એટલા. Do you understand what I am saying? Already those who can pass have passed, most of them. સમજાણું કે નહીં? Most of the students who can pass have already passed. Now by giving gracing you cannot make many more students pass. એવું ક્યારે થાય? When there will be very less number who have passed, so gracing આપો તો ઘણા બધા પાસ થઈ જાય. Make sense or not? Sure? So that's not the case here. So we can say that as most valence electrons of metal are free even at low temperatures, increasing temperature does not increase N significantly. Then is the meaningful. N will increase, there is no doubt about that. Number of free electrons definitely will increase. समझाणो कि नहीं? Number of free electrons will definitely increase. Got it? But that difference or that increase is not that high. કેના જેવું છે? 35 પાસ થઈ ગયા, હવે 2-3 વધુ પાસ થઈ. Change is there, increase is there, but that increase is not big enough. Did you understand? Sure? અત્યારે સમજ પડી ગઈ? Okay, so N will increase. I am not saying N doesn't change. I am saying N does change. It increases, but the difference or the change is very little. That's why this is the main thing. Did you understand? આમાં બહુ change નથી આવતો. So this is nearly constant. Did you get that? N is nearly constant. Now N is nearly constant. આ બધું તો constant જ છે. So it will depend completely on torque. If you increase temperature and that means relaxation time will decrease, so resistivity will increase. समझ पड़ी गई ने? समझ पड़ी गई. So let's write it here. In metal, what happens? As T increases, tau decreases, and that's why rho increases. A simple logic. આટલું તમને યાદ રહેવું. Which quantity does not play important role here? The number days. Is it fine? Sure? Everything clear here? बराबर ने? Let's go to the second part. The second part is for other things, that is semiconductors and insulators. Semiconductors and insulators. Now, what happens in semiconductors or in insulators is completely different. Although, first of all, I want to say that you cannot really use the same formula for both. Why so? Because this was derived from Ohm's law. This was derived from Ohm's law is only valid for not for insulators or semiconductors. Is that clear? Yes or no? But qualitatively the ideas are still same. Think about, first of all, let's think about N, number of charge. If something has more number of charge carriers, then obviously the resistivity will be less. આ ફોર્મ્યુલા જોયા વગર એ સમજ પડી જાય એવું છે. Why? Think of example that I gave you in the morning. If only one student is carrying book from one place to the other place, that is only one charge carrier. If instead of one student, 20 students carry books from one place to the other place, the transfer will happen easily. समझाणो के नहीं? Yes or no? So resistivity will be less. Fine. Just like that relaxation time, I also gave you an explanation of relaxation time. That if every time you are trying to carry the book and go to that place, if someone stops you again and again and again, then what will happen? It will take more time. That is, the transfer will be difficult. Clear or not? The transfer or flow of books will be difficult. Make sense? કેનો ખબર પડી? વારે ઘડીએ રોક રોક કરે તો શું થાય? તો જલ્દી ન જાય ને books આપ બધી. Clear or not clear? So one thing is clear, that whenever n will be more, resistivity will be less. And similarly, whenever tau will be more, then resistivity will be less. આ બે factors તો fix છે. So keep that in mind. Though the exact formula is not valid, exact formula is not valid, but still the ideas are still quite the same. બરાબર ને? જેવું આમાં થતું એવું જ આમાં થઈ શકે. So for semiconductors or insulators, as temperature will rise, obviously relaxation time will decrease. There is no doubt about it. Kev? If temperature increases, what will happen? Random motion will be more vigorous. More random motion will be. So random motion હોય જાય તો relaxation time ઓછો થઈ જ જવાનો છે. Clear or not? That means that factor is trying to increase resistivity. This factor is trying to increase resistivity. But there is another factor here. As temperature rises, more and more free electrons you can say more and more electrons become free. More and more electrons become free from their atoms due to energy supply. Obviously, you cannot increase temperature without supplying energy. I hope everyone gets that. Yes or no? થાય એમને ટેમ્પરેચર ઇન્ક્રીઝ કંઈ કર્યા વગર એમને ચેર રાખી તો ગરમ થઈ જાય. એ રીતે માણસ જ ગરમ થાય. ઓકે, બીજું કંઈ ગરમ ન થાય. Got it or not? Okay, so as temperature rises, more and more electrons become free. Why? Because to increase the temperature, you are going to give it energy, and when the atoms take that energy, they will let electrons go. Clear or not? Okay, so આમાં કેમ આના જેવું છે? That's the difference. If you think of, let's say, a typical semiconductor, silicon. The silicon atom has, let's say, 4 electrons in the valence shell. ये वाज ने chemistry में तुम्हारे. But silicon is not like an S block metal, or not even like a D block metal. Yes or no? એટલે એના electrons કે એમને એમ નો valence shell ના એમને એમ નો જવા દે. Correct or not? It binds to it. Right? Its ionization energy is quite high. Yes or no? Yes. તો હવે આ આવી રીતે બહુ બધા silicon atoms એના electrons એને જવાનું. So the more energy you give, the more atoms will throw their electrons out. समझ पड़े कि नहीं? Right? And this is not same as it was in metals, because in metals even at even at very low temperatures, already energy મળી ગયો કે તો વયા જ ગયા. પછી હવે તમે ગમે તે કરો, it does not make a lot of difference. But here silicon electrons, they are looking towards you. अरे temperature વધારો તો અમે જઈએ બહાર. Okay or not? Because they are not allowed to escape silicon at low temperature, because they don't have that much energy. If you increase temperature, they'll get energy and they will be able to escape and become free electrons. Did you understand? Sure, you got that? Then समझाई गया. So what happens is that, therefore, number density increases exponentially. Number vapor density increases exponentially with increase in temperature. With increase in temperature. Okay. So basically what we are saying is this, but not just increase, but it will start increasing very rapidly. Okay, it will start increasing quite rapidly. So here this is the main factor. These two are opposing directions. I hope you are seeing them. Roughly speaking, rho will be proportional to 1 by n and rho will also be proportional to 1 by tau. So if tau will decrease, relaxation time will decrease, then resistivity should increase. But if n will increase, then resistivity should decrease. So who will win this battle? The answer is this. Because what happens is that even with increase in temperature, although relaxation time does decrease because more collisions. But what is going on over here is that this is an exponential rise. Exponential કોને કહેવાય? એ તો shoot થઈ જાય ઉપર. બરાબર ને? ગ્રાફ કેવો હોય exponential નો? સમજ પડે કે નહીં? Right? On the other hand, as far as the relaxation times are concerned, roughly they are inversely proportional to VRM. समझ पड़े? याद હોય તો KTG में डेरिवेशन આવતું હતું finding relaxation time. એમાં એવું કંઈક આવતું હતું કે distance between two atoms is d or mean free path. Mean free path याद છે? Mean free path distance between two collisions. याद છે? એવું હતું ને? તો એ બધું derive હતું. So T is inversely proportional to VRMS overall. So VRMS is proportional to root capital T. Tau is inversely proportional to VRMS and VRMS is proportional to root of temperature. એવું જ આવે ને under root 3 kBT એવું. સમજાણું કે નહીં? So that's why here you can say that tau is almost proportional to 1 by root T. On the other hand, this is exponential. બેમાં તમે રૂટ નો ગ્રાફ ડ્રો કરો અને એક્સપોનેન્શિયલ નો ગ્રાફ ડ્રો કરો એટલે તરત ખબર પડશે that exponential goes up like crazy. સમજ પડે? બરાબર? રૂટ નો ગ્રાફ પેરાબોલા જેવો આવે. થોડીક વાર વધે પછી આમ ઓલમોસ્ટ ફ્લેટ જેવું થઈ જાય. On the other hand, exponential આમ vertical flat થઈ જાય. આમ નહીં, ઓલી બાજુ flat થઈ જાય. સમજાણું? So it will rise up very fast. So that's why this is the most important thing. ઓલું છે, but it's not that dominant. This wins over there. સમજી ગયા? So we can say that in semiconductors, what happens? Thus, in semiconductors, or same logic is true in insulators also. Ditto the same logic. I will not repeat anything. Okay, insulator માં એવું જોઈએ ને કેમ insulator કેમ હોય? Because it has very few free electrons. જવા જ ન દે. ઓક્સિજન જવા દે? અરે ક્યાંય નથી જવાનું, અહીંયા જો. દરવાજે ન અડવા દે. Is that okay or not okay? So that's why n is very less. So charge carriers જ નથી. ચાર્જ આમથી આમ જાય તો ને હર્ષલને કીધું બુક લઈને જા. પછી એને પકડી રાખો તો. Is that clear? So what would happen? Charge carriers are not able to go anywhere. So charge and flow no થાય. That's why resistivity is very high. समझ पड़ी गई? Sure. So that's what is going on here, right? In semiconductors or insulators, thus we can say that as temperature increases, n will increase much more. Of course, tau does decrease. Okay, but this is the main factor, and that's why what happens? Resistivity will decrease. That's why resistivity will decrease. સમજાણું? Lots of theory in this part of the chapter. સમજવાની વાત છે, કઈ calculation નથી. This we are going to see once again in a better way in the chapter 14. Right? Semiconductors. આખો chapter નું નામ જ છે. બરાબર ને? Semiconductor. Okay. Now there are graphs. for both, for metal and for semiconductors or insulators. બે ગ્રાફ ડ્રો કરી દો. Actually 3 ડ્રો કરવા પડશે. First of all for metal. Metal છે જોજો ગમે ત્યાંનો ડ્રો કરી નાખતા. Okay, so rho and T for temperature. For metals, for example copper, aluminium, simple ones only, it's like this. The graph is like this. Another meaning, as temperature will increase, resistivity will also increase. Got it? समझाना कि ना समझाना? But still, what happens is that for many metals or for their alloy समझ पड़ेगा ना English? What are alloys? A mixture of two metals and sometimes some non-metals. Right? So often what happens is that for alloys and for some metals over a small range of temperature. Small range of temperature means when the temperature is not changing too much. You can say that the rho versus T graph is almost like a straight line. अब ये metals मिलते हैं. Okay, metals or for conductors. Okay, में फर्क શું? This is for a small range of temperature. You know, meaning if temperature does not change very much. Okay, if temperature does not change by a big value, then you can say that approximately the graph of rho versus T is a straight line. Is this true only for one particular or two particular metals or alloys? No, it is true actually for all of them. But approximate કોને કહેવાય? It's not exact. એટલે જેટલો ટેમ્પરેચર ચેન્જ વધારે આવે ને એટલી એરર આવે. And you get that? The reason for that is, you know, although this graph is a curve, no doubt about it. Overall, if you see from 0 Kelvin to higher, this graph is definitely a curve. But for small portions, the graph will be like a straight line. એટલે એવું નથી કે curve એટલે પછી આમ થઈ ગયું એવું નહીં. Okay, the curve is definitely there, but it's a very gradual curve. Make sense? The curve is very gradual. So for small changes in temperature, this is almost like a straight line. Very circle જેવું નથી. Got it? But like I said, the more is the change of temperature, the more error you are going to have by that straight line graph. Next, what about semiconductors? The trend is exact opposite. Like you know, jo metals ma and semiconductors ma ઊંધું છે. I hope everyone noted that. Metals ની last line વાંચો. What do we have? As temperature increases, resistivity increases. So you देखाई जाए graph में. Okay or not okay? Sure. Fine. But for non-metals, means semiconductors, insulators, the result is opposite. As temperature will increase, number of charge carriers will increase a lot, so resistivity will increase. समझाणु કે ન સમજાણું? So એનો graph આનાથી ઊંધો. And like I said, that this change of n is actually exponential. એટલે કેવું થાય કે પહેલા at low temperature, like nearly 0 Kelvin, the resistivity is actually very high. Resistivity is very high. અને પછી જેવું ટેમ્પરેચર વધારે પડે એટલે સીધું exponential decrease. Did you understand? There would be an exponential decrease. Here, like this. Okay, that's very nice. So you should know which is a metal, which is not a metal, and then you should be able to decide based on that. Suppose we take copper and we heat copper, then its resistance will. If we take copper and we heat copper, its resistance will increase or decrease? Increase. Why? Because copper is a metal. Understood? Sure. That silicon at 0 Kelvin and silicon at room temperature. If you compare them, then for silicon, the resistivity or resistance will be less at room temperature and more at 0 Kelvin. Did Did you understand? Okay. એટલે આવું કંઈ પણ પૂછી શકો. Right? Fine. Based on the graph. આમાં ને હા અહીંયા તો આ તો 0 વાળો જ પોઈન્ટ છે. So you know what's the good thing about metals? Most metals, when they go to very low temperature, the resistance becomes nearly zero. Okay. Then there are some special states which are called superconductors. They are called superconductors. થોડું વધારે એક્યુરેટલી ડ્રો કરો તો આ ગ્રાફ છે ને આવો નો. આ ગ્રાફ છે ને અમુક થોડા કેલ્વિન સુધી આવે. પછી એને કંઈક થઈ જાય. તો એ સીધો right, it will suddenly become zero and a critical temperature here, right? At some particular temperature the metal will be converted to a superconductor. સમજાણો બધા મેટલ નું નો થાય but it's common for many of them. પણ આ ટેમ્પરેચર કેવા હોય ખબર છે 1 કેલ્વિન 0.1 કેલ્વિન એવી ટાઈપના ટેમ્પરેચર હોય. They are impossible to achieve in practical scenarios. Okay, that's why we cannot use superconductors in daily life. Okay, समझाणो के नहीं? Probably the highest temperature that we have had for superconductor, if I'm not wrong, is about 150 Kelvin. 150 Kelvin. The highest temperature. Okay. The best thing about superconductors is they have zero resistance, exactly zero, nearly zero nahi, they have exactly zero resistance. So superconductor na wire બનાવ્યા હોય તો એમાં કરંટ ફ્લો થાય તો એક એનર્જી લોસ ન થાય. Is that okay or not okay? Another thing is that superconductors make amazing magnets. Amazing magnets. કેમ કરંટ બહુ ઓછો કરે રેઝિસ્ટન્સ આવો જોઈએ then current will flow very high current will flow. નહીં તો કદાચ તમને ખબર છે 10th માં આવતું હતું electromagnets are those kind of magnets where you pass current, so what will happen? Magnetic field is created. Yeah, they yes. Okay, they are used in trains and all that. In trains maglev trains ખબર છે કે નહીં maglev trains, the ones that don't run on track, they fly off. ખબર છે કે નહીં? Okay, they can go at speeds of 450 km per hour, 500 km per hour. Okay, they're not really bullet trains, they are slightly different. બરાબર ને? In some countries, for example in France, they have trains. The trains have wheels. Then also they run at speed of 400 km per hour. Train જેવી બનાવી. But probably the world record is with China, if I am not wrong, at the moment. The fastest running commercial train. Right? Which has 500 kilometers in 1 hour. બરાબર ને? I have heard, okay, I don't know whether this is true or not, but people in Japan use these trains every day to go to work and to come back home, and probably they travel distances of 400 kilometers, up down 400 kilometers. Right? That would be equivalent of going from Ahmedabad to Mumbai for work every day and coming back in the evening. બરાબર ને? અરે 2 કલાક તો બોમ્બેમાં થઈ જાય. Okay, કે અમદાવાદમાં થઈ જાય if you want to go from this end to that end. Right? Nevertheless, શું કહ્યું તે હશે પેલા આમ rectangular hyperbola draw કર્યું. Okay, fine. So that's about the graph and the theory. Now, equation. See, for metal, when the change of temperature is not that big, we have a couple of relations that we can use. One is this. How 11th model for length. If you remember, when we heat something, then the length will increase. So change in length is equal to L0 alpha delta T. That. So just like that, for a small, I mean generally we don't use it for a very big change. Okay, but for changes in temperature, delta rho means change of resistance. Rho 0 is called a reference or original resistance into alpha into delta. Another one that you can derive from here is as follows. Did you understand this step? Rho minus rho 0. Instead of delta rho, what am I writing? Rho minus rho 0. Okay, and then if I would put rho 0 on that side, then I can take it common. Yes, no. Sure. If you put rho 0 on that side, so you can add rho 0. So rho 0 common. 1 plus alpha T minus T0. Understood? Understood or not? Yes. So this is what we clear or not clear? Okay. Now, this is the relation equal to length my use of the other L equal to L0 1 plus alpha delta T other. Ask with it. Okay, you can of course write that as delta. So these are two relations that we do use. You can write down the terms, it will be helpful for us. Rho for resistivity at temperature T. Rho 0 for resistivity at reference temperature. Reference temperature, and that reference temperature is called T0. Alpha is called coefficient of resistivity. Actually, this is an incomplete name. The whole name is coefficient of resistivity change with temperature. That is, it tells you how resistivity changes with temperature. Okay. T for temperature, of course, and T0 for reference temperature. Okay. A big warning is you cannot use this for any two temperatures. One of them has to be reference. એટલે કોઈ એમ કે આવી રીતે કરાય rho 2 minus rho 1 equal to rho 1 into alpha into T2 minus T1. No, you can't do that. It will only work if this temperature, I mean this resistivity is at the reference temperature. Actually, I mean it's not mentioned anywhere in the book, but if you will understand how this is working, it's that alpha's value depends on rho 0. अलग temperature लो तो alpha ની value अलग आवे, reference temperature अलग लो तो alpha ની value अलग आवे, right? Because alpha is actually telling you this. Alpha equals, if I write this, R. Alpha is the rate of change of resistivity with respect to change of temperature. समझाणो कि नहीं यार? आ डेल्टा रो for small change d rho dt. So alpha तो है d rho by dt into 1 by rho 0. समझाणो? So this is actually a constant. Mu for small change in temperature, the graph of rho versus T is a straight line. याद है? So d rho by dt શું છે? Straight line છે, like slope constant છે. સમજાણું કે નહીં? કેનો સમજાણું? Okay, fine, but alpha depends on rho 0. So if two people will take different reference resistivity, suppose कोई एम के I will take reference temperature 0 degree Celsius, कोई एम के I will take reference temperature 27 degree Celsius, then their values of alpha will actually be different for the same. समझ पड़ी? You know, समझ पड़ी? Right? Because this comes from the graph. There is no doubt about it. एक तो change on. So because of this, what we have is that you should specify what is the reference temperature. એટલે અહીંયા rho 0 જ આવવું જોઈએ. તમે કંઈક બીજું લો તો પછી આ રિલેશન સાચું ન પડે. મને પડી ને? ઓકે. So be careful about that mistake. અચ્છા આ ફોર્મ્યુલા લખીએ તો લખી લો. I don't think we will be using it very often. ક્યાં કોઈ ક્વેશ્ચનમાં ડિફરન્શિએશન કરવું પડે તો. Okay. Now just like this there are formulas for resistance also. This is what कोई पण material હોય, if you take a fixed particular conductor, then a conductor, okay, it will have some resistance, but its resistance is given by R equal to rho L by A. Yes or no? If temperature will change, resistivity will also change. समझाय છે કે નહીં? તો resistivity change થાય તો resistance change થાય ને. So that's why we have similar relations for R. समझाणું કે નહીં? That's why we have similar relations for R. Clear or not clear? Okay. So by measuring change of resistance, we can measure change of temperature. समझाणું કે નહીં? According. There. How does mercury thermometer measure temperature? If it's hot, the length will increase. So by measuring the increase in length, we can measure the temperature. Yes or no? એવું જ હોય ને basically. So e relation આના જેવું છે. તો હવે આમાં શું? By measuring the change or increase in resistance, we can find the change or increase in temperature. સમજાણું? So if you know the reference resistance and the reference temperature, પછી તમે મેજર કરો કે કેટલું રેઝિસ્ટન્સ વધી ગયું. રેઝિસ્ટન્સ કેતે મેજર કરાય? સિમ્પલ, V by I, પાસ કરંટ, whatever current flows, whatever is the voltage, divide them. બરોબર? એટલે શું આવે? રેઝિસ્ટન્સ. તો R મળી જાય. R0 ખબર હોય, આપણે સેટ કર્યું હશે એવી રીતે જ રાખ્યું. Alpha will be known for a material. So based on that you will be able to find out delta T. એવા થર્મોમીટરને રેઝિસ્ટન્સ થર્મોમીટર. What is it called? Resistance thermometer. Why? Because it actually measures resistance. પછી resistance ને temperature સાથે relate કરી and then we measure temperature. સમજાણું? સમજાણું કે ન સમજાણું? Okay? Fine. So please do remember this and this one and this one. બે યાદ રહે તો ઓલું બે આવડી જાવ. Okay? હવે આનો સમ કરી નાખીએ. Right? Take a textbook out. Example 3. 2 બાકી છે ને? 1 આપણે કર્યું છે ને? 2 બાકી છે પણ એ 2 થિયરી જેવો છે પછી કરી લેશું. વાંધો યાદ કરો છો મને નેક્સ્ટ એમાં કઈ છે નહીં ખાસ. 4 કરી નાખીએ પહેલા. 4. ઓકે. 4 is more basic than 3. એટલે પહેલા 4 માં કન્સેપ્ટ સમજાઈ જશે પછી આપણે એને 3 માં યુઝ કરીશું. The resistance of a platinum wire of a platinum resistance thermometer. जो कहते हैं ना, resistance of platinum wire. So there is a wire in a resistance thermometer. केनो बनो છે wire? Platinum. કાઢીને વેચી ન દેતા. Okay. At ice point. Ice point means what? 0 degrees Celsius. So when the temperature is 0 degrees Celsius, how much is the resistance? 5. And at steam point is 5.23. બરાબર ને? એ નહીં 39 આપ્યું છે કોની બુકમાં 39 આપ્યું કોની બુકમાં 23 આપ્યું ઓકે મેજોરિટી વિથ બરાબર ને બીજા નોટબુકમાં આપ્યું જ નથી ક્વેશ્ચન જ નથી આપ્યો નીચે બાજુ સોલ્યુશનમાં બાજુ 5.795 છે બરાબર ને ઓકે એટલે એક કામ કરીએ આપણે 5.23 હું અત્યારે તો એ જ કરું છું કમેન્ટ બુકમાં જે રીતે ક્વેશ્ચન હોય તે તમે કરી નાખો ઓકે ચોઇસ ઇઝ યોર ગમે ત્યાં એક જગ્યાએ તો ભૂલ છે ઓકે everyone got it method will remain same એટલે ટેન્શન ન લેતા method this is clear હવે આગળ વાંચો શું ફાઇન્ડ કરવાનું find the temperature when the resistance is 5.79 अच्छा ये नो temperature 795 okay sorry so we want to find what the temperature here clear or not this is case 0 આ છે ને 0 case 0 એટલે રેફરન્સ okay generally it's a confusion કારણ કે રેફરન્સ ક્યાં લેવાનું ને ઇક્વેશન માં લખતા જ નથી જો આમાં નથી લખ્યું and do you remember what I told you about this that if you take a different reference the answers will be different okay એટલે આ રેફરન્સ આ કેસ નંબર 1 એટલે આને કહી દે ટેમ્પરેચર T1 આ કેસ નંબર 2 ટેમ્પરેચર T2 okay which we don't know this is R0 this is R1 and this is R2 okay did you all read the whole question any other information given is any other information given nothing alpha ne koi nathi aપ્યું ને okay so alpha is not given so somehow we'll have to remove alpha yes or no remove it from the equation so delta r વાળી equation use કરી કેમ સમજાવો હવે બે વાર કરો ને ડિવાઇડ કરો તો alpha કટ થઈ જશે clear or not let's start first of all I write it for 0 and 1 so r1 minus r0 આ delta r સમજાણો કે ન સમજાણો delta r means what change of resistance r1 minus r0 equal to શું લખવાનું right side r0 alpha t1 minus t0 delta t લખો got it or not this is for first we will divide it બીજી વાર એ લખી નાખો ને r2 minus r0 કેમ અહીં r2 minus r1 નો લેવાય ના પાડ્યું you cannot take 2 with 1 you must take reference સમજાણું ને જો એ મિસ્ટેક ન કરતા બહુ ઈઝી સમ છે તમને પૂછે હા ચલો આ લે લે પછી આપે લે પૂરું કરી નાખો માત્ર ખોટો you have to take it as one of the two as reference and r2 minus r0 આ બાજુ કરું તો divide r0 alpha t2 minus t0 સમજાય કે આ સ્ટેપ કર્યો છે ડિવાઇડ કરી દીધું clear or not clear કેજો નો ખબર પડી હોય તો વચ્ચે એક સ્ટેપ લખી દો fine this is for what 0 and 1 and this is for 0 and 2 સમજી ગયા ને 0 1 2 0 એટલે રેફરન્સ what it this is t0 how much t0 બરાબર ને રેફરન્સ ટેમ્પરેચર ચલો બધી વેલ્યુ મૂકી દે આન્સર આવી જશે ને આલ્ફા આલ્ફા કેન્સલ r0 કેન્સલ અહીંયા નો કેન્સલ થયો r1 minus r0 how much 0.23 what it પછી ડિનોમિનેટર માં r2 minus r0 how much 0.795 equal to શું લખું t1 minus t0 100 divided by t2 minus 0 that is t2 got it solve करना पड़ेगा answer will be in which unit celsius કારણ કે આ બધી વેલ્યુ આપણે celsius માં લેવી ઓકે કેલ્વિન માં લો તો કેલ્વિન માં આન્સર આવશે સેલ્સિયસ માં લેશો તો સેલ્સિયસ માં sorry ટેમ્પરેચર યુનિટ ગમે ન આપી શકે ટેમ્પરેચર યુનિટ ગમે આપી દેવાનું ઓકે સેલ્સિયસ કા કેલ્વિન બેમાં સ્ટાર્ટિંગ થી કરો ડેલ્ટા ટી તો સેમ જ હશે ને બે ડેલ્ટા ટી સેમ જ હશે બધું સેમ જ આવશે તો આન્સર અલગ આવશે ટ્રાય કરી દો એકવાર ઓકે બધા કેલ્વિન માં લખવાના ન્યુમરેટર સેમ જ આવશે ડિનોમિનેટર સેમ નહીં બરાબર ને કેમ t0 અહીંયા 0 ના બદલે શું આવી જશે 273 એટલે ઓટોમેટિકલી ચેન્જ થઈ જશે સમજ પડી ગઈ ને it is clear everyone so if you put everything in celsius then temperature will be in celsius you don't have to worry about the unit fine છોડી દો છો Okay?
Yes.
Yeah. Turn it off.